Hello students, in this video lecture we are going to discuss about Zener diode. Before getting into Zener diode, we will first discuss about the reverse breakdowns. When PN junction diode is reverse biased, a small amount of current known as reverse saturation current flows. This current is due to the movement of minority charge carriers across the junction and is independent of applied reverse voltage. If the reverse voltage is increased to a large value, the current through the junction increases abruptly, due to which crystal structure breakdowns. The voltage at which this action occurs is known as breakdown voltage. There are two types of breakdown in the diode. They are avalanche and Zener breakdown. Let us discuss each and every breakdown in detail now. Avalanche breakdown occurs in the diode with wider depletion layer and has less impurity concentration. This effect occurs in diode whose breakdown voltage is above 6 volts. So when reverse voltage is being increased, what happens is that the velocity associated with the carrier increases, which increases the kinetic energy of carriers. These carriers collide with the atom of crystal and impart energy to valence electrons. This energy breaks more over the covalent bond. So more carriers are being generated and this accumulative effect continues and a large current flow through the junction, and such a kind of breakdown is being called as avalanche breakdown, and it is being shown in this animation. So when the reverse voltage is being increased, what happens? The velocity associated with the carrier increases, the kinetic energy of carrier increases. These carriers collide with the atoms of crystal and impart energy to the valence electrons. See here, right? This energy breaks more covalent bonds, right? As this energy breaks more covalent bonds, more carriers are being generated and this is being accumulated, and this effect continues and a large amount of current flows. Such a thing is being called as avalanche breakdown. When it comes to the Zener breakdown occurs when the depletion region is with very narrow and the impurity concentration is of very high. The Zener effect occurs in diode whose breakdown voltage is below 6 volts. So as we keep on increasing the reverse voltage, what happens? The electric field at the junction increases. This electric field is strong enough to break the covalent bond. So large number of minority carriers are generated and a large current flow through the junction, and such a current is being called as the Zener breakdown or Zener breakdown current. So here I have listed down the major difference that exists between a Zener breakdown and avalanche breakdown. So the process in which the electron move across the barrier from the valence band of p-type material to the conduction band of n-type material is known as Zener breakdown, and the process of applying high voltage and increasing the free electrons or electric current in semiconductor is called as valence breakdown. So this is observed in Zener diode having a Zener breakdown voltage of 5 to 8 volts, and this avalanche breakdown occurs when the Zener breakdown voltage is greater than 8 volts. So in the Zener breakdown, the valence electrons are pulled into the conduction due to the high electric field in the narrow depletion region, but in avalanche breakdown, the valence electrons are pushed to conduction due to the energy imparted by the accelerated electrons, which gains their velocity due to their collision with other atoms, as I have shown in the GIF. So here in Zener breakdown, the increase in temperature decreases the breakdown, but in avalanche, the increase in temperature increases the breakdown voltage. In Zener breakdown, the VI characteristics of Zener breakdown has a sharp curve, but in avalanche breakdown, the VI characteristics of the curve is not sharp as Zener breakdown. This Zener breakdown occurs in diode that are highly doped, but the avalanche breakdown occurs in diodes which are of lightly doped. Now let us discuss about the Zener diode. The Zener diode is a silicon PN junction device that differs from the rectifier diode, that is the PN junction diode, because it is designed for operation in reverse breakdown region. The breakdown voltage of a Zener diode is set by carefully controlling the level during manufacture. The basic function of Zener diode is to maintain a specific voltage across its terminal within given limit of line or load change. Typically, it is used for providing a stable reference voltage for use in power supplies and other equipments. Let us see the construction of Zener diode. Zener diode are designed to operate in reverse breakdown, as I have said already. Two types of Zener breakdown in Zener diode are avalanche and Zener. The avalanche breakdown occurs in both PN junction and Zener diode at a sufficient high reverse voltage. The Zener breakdown occurs in a Zener diode at low reverse voltage. A Zener diode is heavily doped to reduce the breakdown voltage. This causes a very thin depletion region. The Zener diode breakdown characteristics are determined by the doping process. Zener are commercially available with voltage breakdown of 1.8 volts to 200 volts. Coming to the working of Zener, Zener diode is much like a normal diode. The exception being is that it is placed in the circuit in reverse bias and operated in reverse breakdown. This typical characteristics curve illustrates the operating range of Zener. Note that its forward characteristics are just similar to that of the normal diode. The figure shows the reverse portion of Zener diode characteristics curve. As the reverse voltage VR is increased, the reverse current IR remains extremely small up to the knee of the curve, that is up to this point. The reverse curve is also called as Zener current IZ. At this point, the breakdown effect begins. The internal Zener resistance, also called Zener impedance ZZ, begins to decrease as reverse current increases rapidly. Zener and avalanche effects are responsible for such a dramatic increase in the value of current at the breakdown voltage. If the impurity concentration is very high, then the width of the depletion region is very less. Less width of depletion region will cause high intensity of electric field to develop in the depletion region at low voltage. Let us take an example to understand things clearly. Let us say the width of the depletion region is 200 amps. That is very small. If a reverse bias voltage of just 4 volts is applied to the diode, then the electric field intensity in the depletion region will be 4 divided by 200. That will be equal to 2 into 10 to the power 8 volts per meter. Merely a voltage of 4 volts is responsible to generate an electric field intensity of 2 into 108 volts. That is very high intensity. This electric field is sufficient to rupture the bonds and separate the valence electron from their respective nuclei. Large number of electrons get separated from their atoms, resulting in sudden increase in the value of reverse current. This explanation was given by scientist C. Zener. Such diodes are called as Zener diodes. Zener effect predominates in diodes whose breakdown voltage is below 6 volt, as I have stressed already. Now coming to the avalanche breakdown, Zener effect predominant on diode force breakdown voltages below 6 volts. The breakdown voltage can be obtained at a large value by reducing the concentration of impurity atoms. We know that very little amount of current flow in the reverse bias diode. This current is due to the flow of minority charge carriers, that is, the electrons in the p-type semiconductor and hole in the n-type semiconductor. The collision of electrons within the atom creates an electron-hole pair. This newly created electrons also get accelerated due to electric field and breaks many more covalent bonds to further create more electron-hole pair. This process keeps on repeating and it is called carrier multiplication. The newly created electrons and holes contribute to the rise in reverse current. The process of carrier multiplication occurs very quickly and in very large number that there is apparently an avalanche of charge carriers. Thus, the breakdown is called avalanche breakdown. The width of depletion region is large when the impurity concentration is less. When a reverse bias voltage is applied across the terminal of the diode, the electrons from p-type material and hole from n-type material accelerates through the depletion region. This results in collision of intrinsic particles, that is electron and holes, with the bounded electrons in the depletion region. With the increase in reverse bias voltage, the acceleration of electrons and holes also increases. Now, the intrinsic particles collide with bond electrons with enough energy to break its covalent bond and create an electron-hole pair. The symbol of Zener diode is shown here. The symbol of Zener diode consists of two terminals, cathode and anode. In Zener diode, the electric current flow from both anode to cathode and cathode to anode. The symbol of Zener diode is similar to the normal PN junction diode, but the bent edge of the vertical bar. It indicates that the current is being flowing in both the directions. The VA characteristics of Zener diode is shown in figure. When the forward bias voltage is applied to Zener diode, it works like a normal diode. However, when reverse bias voltage is applied to the Zener diode, it works in different manner. When reverse bias voltage is applied to Zener diode, it allows only a small amount of leakage current until the voltage is less than the Zener voltage. When reverse bias voltage applied to Zener diode reaches Zener voltage, it starts allowing large amount of electric current. At this point, a small increase in reverse voltage will rapidly increase the electric current. Because of this sudden rise in electric current, breakdown occurs called Zener breakdown. However, Zener diode exhibits a controlled breakdown that does damages the device. The Zener breakdown voltage of the Zener diode depends on the amount of doping applied. If the diode is heavily doped, Zener breakdown occurs at low reverse voltage. On the other hand, if the diode is highly doped, the Zener breakdown occurs at high reverse voltage. Zener diodes are available with Zener voltages in the range of 1.8 volts to 400 volts. Let us now discuss about some of the advantages and applications of Zener diode. The Zener diode has an advantage of power dissipation capacity, and it is of high accurate and small in size, and its cost is of very low. Coming to the application, it is normally used as voltage reference, as well as Zener diode are used in voltage stabilizers, and they are used in switching operations. They are used as clipping and clamping some of the portion of the signals, and Zener diodes are also used in various protection circuits. So that's all about the Zener diode. Meet you all in the next video lecture. Thank you.